Hello dear friends, how are you?
Good morning, Doctor.
Good morning, Doctor. How are you?
Thank you so much. Okay, do you have my voice? Very good. Uh, I hope you are all well and healthy, and I hope you'll be ready for our new course, Numerical Methods for Ordinary Differential Equations. I think some of your friends are absent in this class. Uh, Mainly, this class must be face-to-face, but based on some issues for your friends to get their visa to Iran, study visa to Iran. Now our class will be in virtual type, but after solving this problem for some of your friends, the class will be face-to-face in the rest of this semester. I hope your other friends be in class very soon, but now let me start my course because my class because we have some delays in the beginning of this semester, and now all of you are registered in Golestan system and this webinar system, and there is no any other problems to start this class. The topic of this course is solving ordinary differential equations by using some numerical techniques. Here we want to study some techniques to obtain approximate solutions of ordinary differential equations. I will record our class and I will upload it in your webinar system, UNZ webinar system, and you or some your absent friends can download this recorded file and see again the contents of our class. So I will recording this class. I will record this class. For this course, I want to introduce four main references or main textbooks or references for this course will be these four books, and these books are very famous in all over the world for this topic. The first reference will be the book of Professor Atkinson and his colleagues with this title, Numerical Solution of Ordinary Differential Equations. You can see the title of this reference is the same of the same of the title of our course. Similarly, our second introduced reference will be the book of Professor Butcher, and its title is numerical methods for ordinary differential equations. The third reference will be the book of the Professor Lambert's book, Computational Methods in Ordinary Differential Equations. The first two references will be our main textbooks, but the book of Lambert's book is also a good reference for this course. And the fourth reference will be the book of Professor Champin, Gladwell, and Larry Champin, Solving Ordinary Differential Equations with MATLAB. This reference, the reference book number 4, will be to introduce you some details about a well-known computational software called MATLAB for solving ODEs, or ordinary differential equations, numerically. So, based on these details, first two books, Atkinson's book and Boucher book, will be our main references. Also, Lambert's book is a very good references. Mainly, I will use these two references for your lecture notes, but somewhere we will use the examples or some details in Lambert's book. And the fourth book will be about using a computational software to solve numerically ODEs. We will use the fourth reference for some projects during this semester, and you can study this book if you want to be familiar with a good computational software for solving your problems. Okay, these will be our main our four main references, but now I want to talk about the main goals of this course. I mentioned in the beginning of my explanations, the main purpose of this course is solving ordinary differential equations and numerical. In the rest of this course, for simplicity, I will use the abbreviation ODE instead of ordinary differential equations. So this acronym ODE will be equal to ordinary differential equations. Here we want to present in this course, we want to present some methods to obtain numerical approximations for solution of some initial value problems or boundary value problems related to ordinary differential equations. So we will study two main classes of problems related to ODEs. The first class is initial value problems. The second class of problems will be boundary value problems. In the first part of this course, we will focus on initial value problems. After that, in the rest of this course, we will focus on the second class boundary value problems related to ordinary differential equations. For both of these classes, we will use some numerical techniques. We will introduce these techniques, or we will explain the details of these methods, and we will apply these techniques on some examples to find more results about these numerical methods. Someone who passed this course will be familiar with some discrete will be familiar with some numerical techniques to solve ordinary differential equations, and will be familiar how a student can analyze these methods and their errors, and obtaining some upper bounds for these techniques. If we have enough time, we will focus on some computational softwares to perform these techniques. Our chosen or selected software here will be MATLAB, and if we have enough time, we will focus on how someone can use MATLAB to perform these numerical techniques on some ordinary differential equations. So the main course of this course will be introducing some numerical techniques for ordinary differential equations, analyzing the details of these techniques, working on the truncation error and convergence of these techniques, and finally we will try to perform these analyzed techniques on some examples and some applications to find more details, more results about the ability and the accuracy of these techniques. These will be our main goals. Okay, is there any question, dear friends? Do you have my voice? Everything is okay? Dear friends, do you have my voice?
No, Professor.
Okay, the main syllabus of this course is these topics: approximation of initial value problems for ordinary differential equations. These will be included these subtopics: one-steps method, explicit and implicit Euler methods, the trapezium rule method, and the range kata methods. All of these methods will be in the category of numerical techniques for solving initial value problems. The next syllabus will be linear multi-step methods. Here we will study some predictor character methods. We will focus on consistency, stability, and convergence of these techniques. We will focus on some stick differential equations. We will focus on some boundary value problems related to ordinary differential equations, and we will try to introduce some numerical techniques for boundary value problems. These methods will be included these techniques: shooting methods, matrix method, and collocation method. Also, we will try to use some computational softwares such as MATLAB to perform these numerical techniques, and these topics are our main syllabus in this course. Approximating initial value problems for ODEs by using one-step method, multi-step method, working on stick differential equations, solving boundary value problems, and using some computational softwares. During this course, we will have some homeworks. I will explain you the details of these homeworks, and then you will have some time to solve these homeworks and sending your files through UMZ system or some other platforms. If we have our class virtually, we will have 2 midterm exams. But if you be here in Iran and in the university and our class be face to face, then we will have just 1 midterm. So now, based on our present conditions, we will have 2 midterm, 1 final exam, and we will have some homeworks, and I will assign some grading for these homeworks. If we have 2 midterm exams, then the first and second midterm exams will contain 25% of our final score, and your final exam will contain 30% of your final score, and your homeworks will contain 20% of your final exam. So, based on these details, now we will have 2 midterm exams, 1 final exam, and some homeworks. Okay, these are my main descriptions about this course. If you have if you have any question, I will explain more about these details. But if you do not have any question, I will start the first section of our course in this class. Everything is okay? Everything is clear, dear friends? Is everything okay? Very good. I hope you have my voice, but some of your Mr. Al-Khafaji try to answer my questions, but I think you have some problems, some problem with your voice. I didn't receive your answer because I didn't listen your answer. But okay, uh, if you have any question, you can send me uh, some message or in Telegram or in this system. Okay, here in the first section of this course, I want to talk about some basic definitions of ordinary differential equations. Uh, consider this general form of ordinary differential equations. Here in this equation, we have a function of these elements, t, y, the first derivative of y subject to t, the second derivative of y subject to t, up to the nth order derivative of y subject to t. This function of these elements is equal to 0. This is an equation, and here we have some derivative or some derivatives of the variable y subject to t. You can see in all of these derivatives we have different orders of derivative for function y subject to the variable t. Here we have just one independent variable called t. So here t is our independent variable. So here we have an equation because two algebraic expressions are equal to each other. So here we have an equation. Here we have just one independent variable. This equation will call differential equations because our unknown function y, here we have our unknown function y and some derivatives of y subject to our independent variable. Here we have an ordinary differential equation. So here we have an equation. We have just one independent variable, so our equation is ordinary equation. Our equation is differential equation because we have some derivatives in our equation. So here we have an ordinary differential equation. The highest derivative in function f we call order. So here our equation is nth order. Nth order will be from order n because the highest derivative in our equation is n. Also, we will have another concept about this equation, and it is degree. Exponent of the highest derivative will be called degree. Okay, for example, here in this example, we have an ordinary differential equation because we have just one independent derivative. Y is dependent to t and t is independent. We have just one independent variable. We have some derivatives of or dependent unknown function y subject to t. So our equation will be ordinary differential equation, and here the highest derivative is 2. So our ordinary differential equation is second order, and this highest derivative will have exponents 5. So here in this equation, order will be 2, but degree will be 5. Degree will be 5. Order will be 2. Let me explain again. Here we have an ordinary differential equation because we have just one independent variable. This equation is differential equation because we have some derivatives in our equation. Order is the highest derivative. Degree is the exponent of the highest derivative. You can, instead of this form of your equation, you can consider this form. So here we have two different type of presenting or ordinary differential equation. You can use this. You can use this this format. All of your terms will be in the left hand side and the right hand side will be 0. Or you can use this format. You can bring the highest order derivative in the left hand side and the other terms will be in the right hand side. Here we will have the second format. You can use the first format if you write in this shape d2 d2 dt2 of y to the power of y minus y minus 1 minus t2 equals 0. You can see this will be in this format. So we can show our equation in this form or in this form. Okay, but both of these formats will be the different presentation of one example, one ordinary differential equation. Okay, here we are familiar with the main definitions related to an ordinary differential equation, and I want to explain some other concepts related to ODEs, and the main concept here is the solution of ODEs. What is the solution of ODEs? So when we are work on some ODEs, here we want to find some unknown function. Here in this format or in this example, you can see everything is known instead of except of y. Here the function y is unknown. So y equals y of t will be the solution of all. Here we want to obtain a function y of t that this function will satisfy this equation. So the solution of an ordinary differential equation is a function y of t satisfying in the equation. We want to find this unknown function in our problems. We will have two main classes related to ODEs. The first category will be initial value problems. We need this supplementary, we need some supplementary conditions to find the function y, the unknown function y. So based on these supplementary conditions, we will have initial value problem or boundary value problem. If our main equation, ordinary differential equation, be supplemented with some initial conditions. These initial conditions is y or unknown function is given at some starting value ti, and we want to find y subject to these initial conditions. Then our problem will be initial value problem. So an ODE along with some initial conditions ODE with some initial condition will be called initial value problems. But if we have or ODE along with some boundary conditions. Boundary conditions are specified at more than one t. For example, at 2t, ti and tf. If we have ODE with some boundary conditions then our problem will be called boundary value problem. So boundary value problems are an ODE along with some boundary conditions. So we will have, based on these descriptions, if for solving, for obtaining the unknown function y at an ordinary differential equation, we need some extra conditions. If we have our ODE with some initial conditions, our problem will be called initial value problem. If we have some extra boundary conditions along with our ODE, the problem will be called two-point boundary value problem. Okay, these conditions, these initial conditions or boundary conditions will be used to solve our ODE, to obtaining the unknown solution of our ODE. So these additional conditions will specify these two category of problems. ODE with initial condition will call initial value problem. ODE along with boundary conditions will be called two-point boundary conditions. Okay, the next question will be this question: what is numerical solution to initial value problem? I mentioned previously in the first part, in the first section of this, in the first part of this course, we will focus on initial value problems. So in the present session and or some next or a few next sessions, we will focus on just on initial value problems. Boundary value problems will be worked in the second part of this course. So here all of our problems will be initial value problems. What is numerical solution to the initial value problem? Let me consider this simple initial value problem. Here we have this equation: y prime equals f of t and y. In the left hand side, we have the first order derivative of y dy dt. At the right hand side, we will have a function of the t and y. Here, t is our independent variable, and y is our unknown solution. We want to obtain this unknown solution, and here we have a first order derivative, so the ODE will be from order 1. So Our order will be 1. Order is 1 or first order. So we need just one initial condition. The value of our unknown solution at a starting point t0 of our domain is known. We know the value of y at t0 is equal to y0. It is known. It is known. So here we want to solve this first order ordinary differential equation subject to this initial condition. This is the simplest form of initial value problems related to ODEs. A numerical solution to this problem will give us some approximation of our unknown solution y at some discrete values of independent variables. Consider this sequence of values for our independent variables t1 to tn. These are some discrete values of independent variable t. We want to obtain these values y1 to yn, and these values will approximate the unknown function y at these discrete points. For example, suppose that the domain of our problem is the interval 0 to 1. Here we can consider some discrete points t1, t2, up to tn. So in this domain we considered some discrete points. We want to approximate our unknown solution y at these points. These values, these approximate values, will be shown with this notations y1 to yn. In each point tn, the value of our unknown solution y will be approximated with yn. So in our domain we will select these discrete points t1 to tn. These are the values of our independent variable, and we want to obtain some approximations of y at these points. And these approximations will be notated by yn, and these are numerical estimations of our known solutions. So this problem is defined, for example, on this domain. We will consider these points and we will try to obtain these values at these discrete points. Okay, excuse me friends, we can continue our class. So I explained that we want to solve this first order ordinary differential equation subject to these initial conditions. Here first we will select some discrete points T1 to Tn. We want to obtain we want to approximate the unknown solution y at these discrete points. The notation will be yn, and these values will be the value of y at these discrete points. These values y1 to yn will be approximations of our unknown solution. So in this course, in the rest, we will try to introduce different methods to obtain values y1 to yn. So we will define many different techniques for this aim, and the accuracy of these techniques are different. Some of these methods will give some better approximations for unknown function y. Some other methods will have some some less accurate approximations. In some of these techniques, we will obtain the result in less time. In some other techniques, we will need more times to find a better approximation. So we will try in this course to define different techniques. In some techniques, we will have better accuracy. In some other techniques, we will have some better times to obtaining these approximations. Okay, here I want to talk about in which parts of science we will need face with ordinary differential equations. Let me explain some examples. Consider a simple pendulum. Here we want to consider a small mass m attached to a light inelastic string of length L. So here we have a mass m attached to this point, and here we will have a string of a light a string of length L. We want to swing back and forth in a vertical plane. Let x is a rightward direction and y is a downward direction. So we will have two coordinates, x in the horizontal line and y in vertical uh, we will suppose the string is inelastic, and this assumption guarantee the length does not change and will be fixed L. Also, here we have an angle theta defined by these two coordinates. X equals L times sine of theta and y equals L times cosine of theta. The velocity components in each direction x and y will be shown by u and v. So u will be the velocity component in x direction and v will be the velocity component in y direction. Now when we will now we want to model the movement of this pendulum during this vertical plane. To obtain here, you can see two different forces, m times g in this direction and capital T in this direction will affect on this mass m and will cause the movement of this pendulum. The motion of this pendulum will be governed by these equations. We know the velocity in x direction will be u. So the first derivative of displacement x subject to variable x will be equal to u. The velocity component at y direction will be v, or the first derivative of y subject to y. Also, we will have these two laws based on Newton's second law, also subject to this figure and based on some geometry rules. We know x squared plus y squared will be equal to L squared. So we will have x2 plus y2 equals L2. So for this pendulum, and for the motion of this pendulum, we will have these 5 rules. Now we can rescale our variables. And these are some mathematical simplifications for our problem. If we define some new variables y1 to y5, these equations can be rewritten in this form. Now, if we consider some initial conditions for our 5 unknowns, y1, y2, y3, y4, and y5, if we have the initial value for theta with this capital theta. Then the values of y1 to y5 at 0 will be equal to sine of theta, cosine of theta, 0, and cosine of theta. Now, if we will consider some situations, y1 equals sine of theta and y2 equals cosine of theta, then we will obtain with some mathematical computations, we will obtain this relation, and this will give this system. Now differentiate 103K and 103L and substitute into 103M. Finally will result this equation. Here we have an initial, we will have an ordinary differential equation subject to these two initial conditions. Here our ordinary differential equation will be second order, because we have the highest derivative in our equation will be 2, and for the second order equation we will have two initial conditions. Theta of t equals capital theta, theta prime of t equals 0. This is a simple example. This is a simple example of application of ordinary differential equations in real world. In the other words, the movement and the motion of the motion of this pendulum in real world can be formulated by this, can be modeled by this second order ordinary differential equation subject to these two initial conditions. This is a very famous example in the field of ordinary differential equations, and in this example you can see the you can see how we can model a real world problem with some initial value problems based on ODEs. We can consider more examples. For our second example of applications of ordinary differential equations, let me consider an example in ecology. We want to consider a population of predators and prey living in an ecological need. The predators survive by eating the prey, and the prey exists on an independent source of food. So we have three concepts: predators, prey, and source of food. A classical let me show the population of predators by capital P of T and the population of the prey by P of T, small p. We will have an initial population of these two classes, and these initial values will be capital P and small p. Capital P is the initial population of predators, and small p will be the initial population of predators. Based on the works of two professors, two scientists, Lutka and Walter, we will have this system of ordinary differential equations. Here, the parameters A, C, alpha, and gamma will be four positive known constants. A is the prey's natural growth rate. C is the predator's natural death rate. Alpha is the prey's death rate, and gamma is the predator's growth rate. These four known constants these four parameters are known based on the details of our ecological environment, and we can use these two equations subject to these two initial conditions to obtain values of capital P, the population of predators, and small p, the population of prey in each positive time t. So here we will have a system of two ordinary differential equations subject to these two initial conditions. So here we have a system of ODEs. We need to solve these two equations we will need to solve these two equations subject to these initial conditions with each other. We need to solve these two equations to obtain the unknown functions small p and capital P. These here the values of A, alpha, C, and gamma is known, and we want to solve this problem. These examples are two famous applications in real world that will be that is resulted to some ordinary differential equations. In the first example, we saw that the motion of pendulum can be modeled by this second order ordinary differential equation subject is to initial conditions. And here we saw that the population of prey and predators can be modeled by using this system of ODEs, subject these to initial conditions. Okay. Now we are familiar with the main concepts in the field of ordinary differential equations. In this class, we talked about the main definitions and main concepts in the field of ordinary differential equations. We defined the main concepts of numerical solution, and I think it's enough for our today's class, and we can continue our discussion in the next session in Wednesday. Okay, it's enough. Dear friends, do you have any questions about our today's class? Mr. Al-Khafaji, I cannot receive your voice. You can write here in the right hand side column. Mr. Sharif and Mr. Ashar and Mr. Abdul Wahid. Do you have my voice? Do you have any question?